Hi, the topic of today's program is land and its resources. We are all aware that God has created the earth with abundant natural resources which is of benefit to mankind. Now, let's look at minerals in the earth's crust, which comprises of natural mineral elements and natural mineral compounds. The Earth's crust is a thin layer found on the outer section of the Earth. There are various minerals that can be found in the Earth's crust. Minerals make up the bulk of the materials in the Earth's crust. These minerals are widely used in the building industry, transportation industry, agriculture, and as natural fuel resources. Minerals exist in the crust in the form of natural elements or natural compounds. Natural mineral elements are those minerals which exist as free elements. They can exist as elements because they are not active and they cannot combine with other elements. Examples of natural mineral elements are gold, silver, copper, lead, platinum, mercury, and arsenic. As for natural mineral compounds, they are minerals which are present naturally in the Earth's crust as compounds, or in other words, they are formed from active metals which have combined with one or more non-metals. Most minerals are found as natural compounds in the form of oxides, sulfides, carbonates, and silicates. Examples of natural mineral compounds are tin ore, clay, and limestone. The natural mineral elements and compounds have existed in the Earth's crust for more than 2,000 million years. These natural minerals are very hard and do not dissolve in water. Its hardness can be referred to its resistance against erosion and scratches. These natural minerals also can withstand high temperature. For example, minerals like metal oxide and silicate normally do not decompose when heated. Metal oxides are very hard and do not dissolve easily in water except for potassium oxide, sodium oxide, calcium oxide, and magnesium oxide. These soluble oxides dissolve in water to form alkalis. Metal oxides do not decompose on heating except for mercury oxide. Mercury is a natural element, so it cannot hold on to its oxygen tightly. Hence, little heat is required to separate the mercury and oxygen. Metal sulfides are hard minerals, do not dissolve in water, and they react with oxygen when heated, except for potassium sulfide and sodium sulfide. Potassium and sodium are very active elements, so they hold on to the sulfur very strongly. Most metal carbonates are very hard minerals. They cannot be scratched even with a steel knife. Metal carbonates are not soluble in water except for potassium carbonate and sodium carbonate. Metal carbonates decompose when heated to form metal oxides and carbon dioxide, except for potassium carbonate and sodium carbonate. In these experiments, we need to have test tubes, boiling tubes, beakers, spatula, rubber stopper, test tube holder, delivery tubes, retort stand, Bunsen burner, and lighter. As for the materials to be used in this experiment, we will need iron oxide, tin oxide, iron sulfate, magnesium sulfate, calcium carbonate, copper carbonate, and distilled water. For the hardness of minerals, we can conclude that all minerals are hard and can only be blemished when scratched by a nail. In this experiment, we are going to study on the solubility of all minerals that we have listed previously. First, we put in a spatula of mineral sample, that is iron oxide, in a test tube. Add distilled water about half full and shake it vigorously. Then, we repeat the same procedure by using tin oxide. Thirdly, we repeat again using iron sulfate. Fourth, with magnesium sulfate. Fifth, with calcium carbonate. And lastly, with copper carbonate. We need to observe whether the mineral that we put in can dissolve in water. So now, we can conclude that all minerals that we have tested are not soluble in water. The mineral elements can be classified into two main groups, which is metals and non-metals. Metals are extracted from the mineral ores found within the Earth's crust. A metal is an element with a surface that is shiny, ductile, and malleable. Examples of metals are zinc, magnesium, sodium, iron, copper, lead, gold, and silver. They are good conductors of heat and electricity. They are solid and have a high melting and boiling points. A non-metal is an element with a surface that is dull and brittle. Examples of these are graphite or carbon, sulfur, oxygen, and chlorine. For this experiment, we will need boiling tubes, Bunsen burner, retort stand, spatula, crucible, glass wool, lighter, forceps, potassium manganate 7 crystals, aluminum powder, zinc powder, iron powder, and magnesium tape. First, we need to put a spoonful of potassium manganate 7 crystals into the boiling tube. Clamp the boiling tube horizontally to the retort stand. Then, take some glass wool with the forceps and insert it, placing it before the potassium manganate 7 crystals. Take a spatula of aluminum powder and place it before the glass wool. Now, close the opening of the tube with some more glass wool. We have to put the glass wool in between to prevent potassium manganate 7 crystals from mixing with the metal. Otherwise, an explosion might occur when the mixture is heated. The glass wool is also to prevent the oxygen produced from escaping quickly. Now, heat the aluminum powder and the potassium manganate 7 crystals. Potassium manganate 7 crystals, when heated, releases oxygen. This experiment is repeated by substituting the aluminum powder with zinc powder. Next, we use iron powder. And lastly, we will just burn the magnesium tape in the crucible with a lighter. The result of these experiments between metals and oxygen is as such. Most reactive is magnesium, which burns very quickly with a bright white flame, followed by aluminum, which also burns with a bright flame and spreads quickly. Then, by zinc, which also burns with a bright flame and spreads slowly. And lastly, the least reactive is iron, which glows and spreads slowly. We can now conclude that most metals react with oxygen at high temperatures to form metal oxides, which means magnesium, when heated, reacts with oxygen to form magnesium oxide. Aluminum reacts with oxygen to form aluminum oxide. Then, zinc reacts with oxygen to form zinc oxide, while iron reacts with oxygen to form iron oxide. In this experiment, we need to have a Bunsen burner, boiling tube, test tube holder, retort stand, spatula, sulfur powder, magnesium powder, aluminum powder, zinc powder, and iron powder. First, we need to put 1 spatula of sulfur powder into a boiling tube. Add 1 spatula of magnesium powder and mix it. Then, clamp the boiling tube to the retort stand. Light the Bunsen burner and heat the boiling tube slowly until it glows. Repeat using the same procedure by mixing sulfur powder with aluminum powder now. Then, sulfur with zinc powder, and lastly, sulfur with iron powder. The result of these experiments between metals and sulfur is as such. Most reactive is magnesium, which burns very brightly, followed by aluminum, which burns brightly, and zinc, which glows very brightly, and lastly, iron, which glows brightly. We can now conclude that metals react with sulfur to form metal sulfides, which means magnesium reacts with sulfur upon heating to form magnesium sulfide. Aluminium reacts with sulfur upon heating to form aluminum sulfide. Then zinc reacts with sulfur upon heating to form zinc sulfide, while iron reacts with sulfur upon heating to form iron sulfide. The mixture of metal powder and sulfur powder glows upon heating. The glow spreads through the mixture and will catch fire for the active metals, even when the initial heating is stopped. This shows that the reaction releases heat energy. Now everyone, let's recap what we have learned today. Number 1. Minerals are elements or compounds that exist naturally in the Earth's crust. Examples of natural elements are gold, silver, and platinum. They exist as elements because they are inactive and cannot combine with other elements. Number 2. Most of the natural compounds exist as oxides, carbonates, sulfides, and silicates. Number 3. Most metal oxides, carbonates, and sulfides are hard and do not dissolve in water except for potassium oxide, sodium oxide, calcium oxide, and magnesium oxide. They dissolve to form alkalis, that is, potassium hydroxide, sodium hydroxide, calcium hydroxide, and magnesium hydroxide. In the case of metal carbonates, only potassium carbonate and sodium carbonate dissolve in water. All metal sulfides do not dissolve in water. Number 4. Most metal oxides do not change when heated, except for mercury oxide. When heated, it separates the mercury and oxygen. Number 5. Most metal carbonates decompose to form metal oxides and carbon dioxide upon heating. Number 6. Most metal sulfides decompose to form metal oxide and release sulfur dioxide gas when heated strongly, except for potassium sulfide and sodium sulfide. They are very active elements that hold on to the sulfur very strongly, so they do not release sulfur dioxide. Number 7. Most metals react with oxygen and sulfur to form metal oxides and metal sulfides respectively. Minerals are found as natural elements and natural compounds which have many valuable uses for mankind. Understanding its chemical properties help us to harness its usefulness in many industrial applications.